Welcome back, AI agents. So, as we've been building on this stack of technology, now we arrive at AI agents. And AI agents are really the biggest phenomenon right now in the world of AI. So, up until now, the workflow that we've been looking at, which is a non agentic workflow, has been a zero shot setup. It's a one pass operation. Say, if you ask the LLM to write an essay about something, it just predicts the next token and the token after, so on and so forth, and until the essay is complete. This is similar to asking a human to write an essay without ever backstroking or deleting anything. A very difficult task to do for a human, and an LLM does a surprisingly good job of that, but it could do a much better job if it could go back, think about it, do some research, revise it, so on and so forth. Now, in the agentic workflow, you allow the LLM to iterate and to think. Say, if you ask it to write an essay, what it does is that it can think about it, it can plan how to proceed, use tools to do research and web search and such, and write something, revise it, review, maybe iterate a couple times, and then what will come out of it is going to be much better than what it would be able to do with a zero-shot setup. And there are benchmark studies that actually show that if you take a simple LLM embedded into this agentic workflow, its performance on this benchmark data set or tests is better than heavier, more powerful LLM. Just by virtue of allowing it to iterate, it becomes better than more powerful LLMs. So what makes agentic workflow are two things. One is planning, and two is iteration. So if you can create a software product that it can plan its actions and it can iterate as many times as necessary, you have created an agent. Now, speaking of which, I'm going to bring to your attention the example from last week, which was integrating tools into LLM or function calling. And I had a single tool which was for getting weather forecast. And here, the user is asking, what's the weather in Tokyo? It sends it to the LLM. The LLM calls a tool, which is the weather API. So far, so good. But what happens next was kind of hand-wavy. We could either just get the output from weather API and send it back to the user, or write another piece of code that once it gets the output from the tool, send it back to the LLM for the final response. So that already shows the gap that agent can fill, which is the idea of letting the LLM, letting the agent figure out what to do next. Should it iterate more, or is it done and return the response to the user, right? Now, with that said, I'm going to show you some existing agents so you have better intuition for it. Okay, so here's the first example, Grok. So when you go to Grok, you're actually interacting with an agent. You're not interacting directly with the LLM, but by a software shell around it, which is the agent. And here's an example of that agent in operation. So here's what I'm saying. Using the attached CSV file, what would be a reasonable price for a house that is 3,000 square feet? Now here's the CSV file. So you have area and you have house prices. So you want the agent to take this file, open it, read it, think about it, and figure out what the price of a house should be. So let's run it. You see reading attachment. So this is agentic workflow, meaning I didn't specify how to proceed, what steps it should take. It figured out, okay, first I need to do this. It planned the actions to go get the file, read it, and then figure out what to do next, or come up with a response. In the second example, I'm asking Grok to summarize crime patterns in the past 6 months in Philadelphia. Again, because it's agentic, it's going to plan the actions and figure out, first I need to do a web search and figure out and get data off of the internet before I can analyze it and write a response. So I'm going to run this and watch. Searching Twitter or X and searching internet. And then the analysis come next. So again, what's embedded in this agent is this notion of planning and executing on the plan and iterating. So my favorite example is Cursor because it shows you the agentic and non-agentic workflow, right? So here I'm asking Cursor to create a Python code repository for a complete spam email classification product. And here I have three options. I have ask, edit, and agent mode. Ask is just a one-pass operation, non-agentic. So if I start, it just predicts the next token, so on and so forth, right? Now, if I use the agentic workflow, it's not just gonna predict the next token and pass it to me, but rather it's gonna plan it, take action, and iterate. So what happened here was that it figured out, well, the next thing I need to create the file structure. And it ran a terminal command and created that file structure. And then it created the files, and you can see the code and so on and so forth. Now, it does ask for your acceptance or for your permission before making these changes. That's something you can play around with the settings. But nevertheless, this is an agentic workflow. Now, I want to demystify the AI agent. I want to look under the hood. And what you will find is that it's actually pretty simple. You can build it yourself from scratch. So if you think about what makes an agent, the ability to plan, execute, and iterate, it's common to come up with this architecture of having three components. One is to reflect, think about it, think about the request or the history or everything that has been done. The next component is planning. All right, given what I understand of the situation, what do I need to do? You can come up with the list of everything that you need to do, or just identify the next task. And then the execute operation is to just execute on the plan. Now, for the execution, very often you need tools such as web search or access to the email or calculator or Python script, something like that. With this iterative approach, with this agency of this software to take action, think about it, do the next step, now there's a paradigm shift. And that is, in the non-agentic one, the idea was that you ask a question and you get an answer. In the agentic workflow, you give it a task and you get the task completed. That's a paradigm shift. And the reason you could go from questions to tasks is the fact that tasks could have many steps involved in it, and the agents are designed to do that. All right, now, how do we do the planning and reflection? Well, we use the LLM. So even though you don't see LLM anywhere in this picture, each of these components might be communicating with an LLM, all right? So the LLM is the reasoning engine in the back of the AI agent. Next, I want to write the code for an AI agent from scratch. And the whole idea is to demystify this AI agent and make you realize that it doesn't have to be complicated to have a bare minimum AI agent. This is the entirety of a code for an AI agent. I'm going to walk you through every line of it. So I'm importing requests so I can make HTTP requests as part of my internet access. I need OpenAI so I can communicate with a large language model and a regular expression. There are no imports of agent-specific libraries here. So this is agent written from scratch as opposed to using some existing libraries. Next, I will show you a code using existing libraries, but here it is bare bone written from scratch. All right, so I define a class for the agent called Research Assistant. Here my Thinking is that I will create an agent that does research for me off of the internet. And it has two attributes. One is the client, which is the LLM. And here I establish my credential with the LLM. And I will use this LLM to reflect and to plan. And a memory. The memory is going to be this object that holds the entire history of the conversations. This would be the prompt that feeds into the LLM. So the LLM will see the memory, and I pre-populated it by system message that says, you're a research assistant, you can use these tools, just give it context. Next, I define 3 functions. One of them is call LLM, which does exactly what it suggests, so that during the reflection or planning, I can call this function to call the LLM. The web search and calculate functions here are just the tools that I have available in my agent. I could have more, but right now I just have one function for web search and one function for calculations, or a calculator rather. Now, these are the main components of the agent. I have a reflect function, which essentially has a prompt, and then it calls the LLM with that prompt. And the prompt says, you've been given this task, and this is the history up until now. Think about it, reflect that what needs to be done. And this is the opportunity for the agent to think. I have a plan function, which again makes a call to LLM, says, given this reflection, given this history of the conversations, tell me what is the next thing I need to do. And I have the execute function. So first you did a reflection, then you plan the next step, and now the execute function executes on whatever plan determined needs to be done next. And here I have a web search. It says, well, if the plan is to web search, run the web search function. If it's to calculate, do that. But if it's finalized, that will be the final response from the agent. Next, I have the research function. And this is the important wrapper around all those separate components. This is the one that iterates a loop until it's done. It says, while true, reflect, then plan, and then execute on that. And if the plan says that you're done, then you're done. Otherwise, keep doing this thing. Keep reflecting, planning, and executing. Right? So this is the entirety of that agent. And now to use the agent, well, I define it as an instance of the class. The task is to calculate the average global temperature since 1900. And now I run the research. And when I run this, it's going to keep iterating, looping over reflection, planning, and execution. So these are some of the main components of AI agents. And you could get creative. There is no divine rule on what elements should exist. You can combine reflection and planning into one function, or you can really outsource them to different agents. You could have an agent that does only planning, So there is flexibility there, but the idea remains the same. Now, what I presented to you was writing the code from scratch. You had to create this memory. You had to create this called LLM function. But since these are common steps, the Langchain library and probably some other open source libraries have already written the code base for all that, such that you can just call those functions and minimize the amount of code you have to run, right? So this is the entire code you need to create an agent using Langchain. You import a bunch of functions from Langchain. You define your LLM, and the only tool I have here is the search tool, and then I create my tools list. I create an agent. The React agent here, React stands for reflect, act. So this is the paradigm that we actually looked at when I created our own code from scratch. So essentially, what you're saying is that I want to create an agent of a React type using this LLM and has access to this tool, which is just search. And now you can invoke that agent. This is kind of like that research function that I had before, and it says, what's the weather in New York City? So I ran the code. It took me 8.8 seconds just to ask, what's the weather in New York City, and get this response. And there's a fundamental aspect of using agents. If you've played around with LLM, you're probably expecting fraction of a second in response time. But with agents, it can take a while because it has to go through that iteration. And it's not uncommon for some of these agents to take minutes or hours to complete a task. Now, what is neat here is Langchain makes this option available to you to see the trace of these activities under UI. So if I go to Langsmith, you can see the trace of this. I'm going to click on it. Different runs of it, and the latest one took 8 seconds. You can see everything that happened as part of that agent's run, right? So you started that, and then you went to the agent called the tool, that was a search, and then the result from the tool went back to the agent, and the agent gave you the final answer. And all of that is also available here. So this was the user message, and then the tool was called with this argument, was the weather in NYC. It did a web search, and then the result came in. This was the result from the tool. It was fed back into the LLM, and that was the final step. So we talked about what AI agents are, and we looked under the hood for a simple AI agent to see what the components are. In the next lecture, we will talk about the landscape of these AI agents and multi-agent setups.